Hello everybody, welcome back to another video lesson. Today we are doing Chapter 8, Lesson 6, Changes in Dimensions, and your assignment was on page 645, numbers 1 through 6. Now these questions are a little bit intimidating when you first look at them, but when you dive into what you're actually doing, it's pretty simple in the ideas that we're going to apply, okay? So we're talking about changing surface area and changing volume, okay? And if you remember two key things, it makes these questions very easy to solve, okay? If we're changing the surface area, okay, and think about area, okay? Think what makes area for a second. If we're changing the surface area by a scale factor, what we're going to do to find the new surface area, okay, I'm going to represent that with NSA, right? That's the new surface area. What you have to do is you have to take whatever the old surface area is, the original, okay? So you take the original and you multiply it by your scale factor. But here's the tricky part. Since it's surface area, remember that area, square area, right? I'm sure you've heard that term at some point, area, square area. Since we're dealing with surface area, this scale factor is going to be squared. And that's how you would find the new surface area for a similar shape or a similar figure. Right, we're just changing the dimensions, and this is a nice, easy formula we can use for all of these surface area questions. If we're talking about volume, well, the new volume is going to be very similar to surface area, where you're going to still have your original volume, but now you're going to multiply it by your scale factor, and what makes volume volume? Well, volume is always cubed. So your scale factor is also going to be cubed, okay? So if you remember those two key details, that makes these questions a whole lot easier, okay? So I'm going to do question, let's do question 4, and we'll start question 5. So 4 and 5 for today. So with question 4, once again, so 1 through 4, we're dealing with surface area. So you're going to use that first idea where you're squaring your scale factor, right? So on question 4, we have a glass display box, and it has a surface area of 378 square inches. How many square inches of glass are used to create a glass display box with dimensions that are 1/2 of those original, right? So we're dealing with surface area. So I'm going to write new surface area is going to equal my original surface area, which was 378 square inches, times my scale factor, right? And our scale factor here is we want it to be 1/2 of the original. So my scale factor is 1/2. And since we're dealing with surface area, that 1/2 is going to be squared, right? And we know that 1/2 squared is just 1/2 times 1/2, which is 1/4. So this is really 378 times 1/4, and if I do 378 times it by 1/4, you will get 94.5. Since I got to use my unit, which is inches, and since it's still surface area, it's got to be squared. Okay, so my new surface area, right, if I have dimensions that are 1/2 of the original, you will get a surface area that's only 94.5 inches squared. Okay, so taking a look at number 5, we're dealing with volume. So my new volume is going to equal my original volume, which is 9,728 cubic millimeters. And we're trying to find the volume of a similar cone with dimensions that are 1/8 of the original. So we're going to multiply this by 1/8, but since we're dealing with volume, that 1/8 is going to be cubed. Okay? And if you type that all out and you figure out what your answer is, that will give you what your answer is. Keep in mind it doesn't have us round anything here, so whatever you get as your answer is your answer. Okay? Keep in mind on this one, your unit is millimeters, and then it should be cubed. So whatever you get for your answer will go on that line, and that's going to be millimeters cubed. Okay, so 1 through 4 are surface area. your scale factor is going to be squared. 5 and 6, you're talking about volume, so your scale factor is going to be cubed. Okay. If there's anything confusing about these questions, or if you still don't understand, please make sure you email me and get in touch with me, and I'll try to help you out as soon as possible and at the best of my ability. Okay. I hope you're staying safe, hope you're staying well, and I hope you have a great day. Thanks.